Welcome. This is the new NanoVNA-F that I got from Amazon. We can bring up the menu here. And I'm going to turn off all of these traces. They put them on initially, but I don't like most of them. And so I'm going to leave it like that. So what this is showing is S11, which is going to allow me to measure my antennas and see how well they perform. These are some of the items that come with it. This is a load up here. This is a short. This is an open. But this thing comes calibrated. When I got it, it was calibrated to this port right here. And so I didn't need to use those right away. And it's very compact. This is the larger one. This is 4.3-inch screen. And I put it next to my cell phone over here so you can kind of see how it compares in size. So we're going to go over to the ham radio, and I'm going to show you how my antenna performs as displayed on the NanoVNA. But before we do that, I just thought I'd point out something here that's pretty amazing. This is a commercial unit down here, and these things cost tens of thousands of dollars. And the NanoVNA is just about equivalent to this. Not really, of course. This thing is an 18-inch rack mount. And I don't know how high, probably 15 inches high total. It's in two boxes. This is the main unit with the display and the controls. This is what's called a directional coupler, and that's pretty much effectively built into the NanoVNA. So you get all of this, which normally sells for tens of thousands of dollars new, or at least several $1,000s used. And we're going to do that with the NanoVNA. So this is my ham radio. This is a SB102, and the case is off because I had some issues with it, but got those fixed, I think. This is my antenna. It's on the back of my house. It's a 4BTV, I think is what it's called. It's a multi-band antenna, and it's not mounted very well. It's right next to the house, so it's going to detune it with the gutters. But it's a multi-band vertical, as you can see. And when you put one of these up, you have to tune the various radials, and you can see up there there's only 2 radials, and I only have 2 radials here as well, and I had to do that, I think, because of the gutter here. But tuning these is quite a trick, and the VNA can help. And here's how well that antenna is performing. I've got the NanoVNA set up to sweep from, let's see, start frequency 3 megahertz, stop frequency 23 megahertz. I didn't go all the way up to the 10 meter band, but this covers most of the bands. And the marker right now is over here, and it's currently set at 7.2 megahertz. So that's our 40 meter band. It looks like it's tuned a little low. If I move the marker down here, it reads 7 megahertz, but it works fine up to 7.4. How do I know it works fine? Actually 7.3 probably. There's 7.2. The reference level is right here. At this point you can see the little triangle here. That's saying that that's 0 dB return loss, S11. What you want is at least 1 division down, which is like here. And so this is like 2 divisions down. This is a very good 50 ohm load, a very good SWR, and everything is fine. Some of my other bands, not so much. So let's take a look. I'm going to move the marker. So I'll move this up. Let's go up to the 20 meter band. So I'm at 14.2 now. So that one is not quite 1 full division down from the reference level. So you go from the reference level, from here down to there. Not quite 1 division, so probably needs a little tuning, but it's not terrible. If I go on up, look at the 15 meter band, it needs work. So this is 21.2, and we're not even getting very good. And also the low band, the 80 meter band down here at the bottom. So I'll move the cursor way down there at the bottom. Just a little bit of a dip there at 3.7 or so. let's take a closer look at the 80 meter band down here. So I'm going to bring up the menu, change the start frequency to 3.5 megahertz, and let's change the stop frequency to 4 megahertz. Okay, that's better. So it wasn't taking enough points before, and now it is taking enough points, and it looks not horrible. However, we got to figure out what frequency this is. I think that's 3.7. It's probably where I tuned it originally. So it's okay from about 3.725. It's good at 3.7, and oops, pretty good at 3.665. So that's a very quick intro to some of the things you can do with your NanoVNA. I did not tell you how I have this hooked up to the antenna, so let me zoom out here. So I currently have a SMA to BNC adapter, and then I've got a BNC cable that I ran over to my radio set where it has the PL259 connectors. So you're going to need probably some adapters, and you can get those from Amazon or eBay or wherever. One other interesting things you can do here, S11, we'll cover that in another video, but essentially it's measuring the ratio of what comes back to what went out and converting it to dB. And if you look at this point right here, it's about 2 dB down. I can run the marker over there and we can see, but it's about 2 dB down. What that tells me, now this is outside the band of where the antenna is working, so I should have pretty much full reflection at that point. And what that tells me is that the coax loss from my office here where I have the radio out to the antenna is probably about 1 dB in each direction. So it's reading a total of 2 dB down here, and I would infer then that I've got about 1 dB of loss from the radio out to the antenna, and that's not bad. So that's another neat thing you can do if you switch from thinking about SWR to embracing this thing called S11. So that's it. I hope you enjoyed this quick intro to the NanoVNA. There are a lot of other videos out there, and I'd encourage you to look at them, like unboxing the NanoVNA and some basic use scenarios for it. But what I think I might add to what's already out there is shown here, some possible future videos on these units. So I mentioned in this video that S11 is in many ways a much better way to assess your antenna performance than SWR. And in order to explain that, I would need to define S11. And then there's something also called S21 for amplifier gain measurements. So I might make a video on this general topic of S parameters. Also, since they're based on forward and backward traveling waves in transmission lines or coaxes, it makes sense to do a video on forward and backward traveling waves. What really are those, and how do they work? And then a really cool thing you can do with this NanoVNA is you can use it as a synthesized signal generator. So I might make a quick short video on how to do that. You will need probably for many applications a step attenuator, but you can get those on eBay or somewhere. So the NanoVNA, the one I have, puts out about +2 dBm, a little over 1 milliwatt of output power. And if you want to use it as a signal generator, you might want to control that output power, make it a lot less if you're testing a receiver. So you would need a attenuator. And so I'll show that in a video perhaps. And then depending on how hard it is to cover these topics, we might need some math. I mean, that's what radio art is about, is capturing the physics and the mathematics. It's not going to be complicated stuff. We can do this with algebra, possibly some complex numbers, but this would be a later video where we talk about what S11 and SWR really are in terms of mathematics. And then, of course, Smith charts. I'm sure there are lots of videos out there on Smith charts, but I'll try to make one too. That's it. Thank you.